Hi, fourth graders. So this is the third out of three review pages for our Unit 8 test. Here I am on page 345 of my math book, and I'm going to start with number 15. Draw one diagonal in the figure to form two obtuse triangles. Okay, so I have to remember the vocabulary word diagonal, and I have to remember that that means that it is a line that's going to cross from one corner to another of my quadrilateral, and it will be opposite. So the best strategy to use here would be to do a very light line between those two corners, and then a very light line between these two, because then I'm going to see my options, my choices, because probably one of these is going to not form two obtuse triangles. Okay, so maybe I should have tested one of those out at a time, actually. This is a good mistake for me to be making so you can kind of see, because if I draw them both at once, it's going to be too confusing. Okay, so let's check this one out first. Does this form two obtuse triangles? Well, I remember that an obtuse triangle has to have one obtuse angle in it. This triangle on this side has three acute angles, and this one over here also has three acute angles. So that would be wrong. If I drew my line that way, it would be incorrect. Let's try it the other way. So remember, a diagonal has to be from opposite sides. I'm pretty sure this is going to be right, so I'll go ahead and draw it darker because there's really only two choices on here. Okay, so are these two triangles obtuse triangles? All right, well, remembering that I have to have at least one obtuse angle in each triangle, yeah, there's an obtuse angle and there's an obtuse angle, so I have drawn my diagonal. Okay, number 16, does the figure have a line of symmetry? Explain. Oh, I remember this one from last year. A lot of the fourth graders got it wrong because they thought if you would draw a line there, that folding this on top, they would match. What do you guys think? Do you think it would match? No, it doesn't. It does not have a line of symmetry, so I better erase that line, right? So I don't confuse myself. It does not, and then of course you have to explain. Your explanation could say something like, it is not possible to draw a line across the figure to divide it into two matching parts. You could say something like, if I would fold it over the line, one side would be smaller than the other side, something like that. Number 17, a Ferris wheel turns 35 degrees before it stops. Oh, okay, so here's our Ferris wheel. It's turning this way, and the yellow angle is showing us 35 degrees before it stops. So it stops there. Then it turns another 85 degrees, so that's my red angle, before stopping again. I love being on Ferris wheels when they stop like this. Okay, what is the total measure of the angle that the Ferris wheel turned? So it went 35, and then it went 85. If you added 35 and 85 together, you would get 120 degrees. And that, again, you'd probably have to do on scratch paper just to make sure you can double check my math. Part B, how many more times will it need to repeat the pattern to turn 360? Again, this one was tricky last year for fourth graders. So it's already turned here. This is where we're at. I'm going to do like a really dark little arrow there. Sorry to that poor person in that cart there. That's where we're stopped. And we want to get back to there. So how many more turns like this one, like this 120 degrees, would it have to do to get back? Well, there's a couple of different ways you could think about this. How many 120s do you guys think are in 360? So I already have one 120. If I added another 120, what would I get? I would get 240. And then if I added another 120, I'm going to show my work down here to make sure I've got this right. Oops, you didn't see that. 360. So that means 3 120s add up to get 360. If that's the case, how many more times does this have to turn to get to 360? It's already turned 1 to 120, so how many more 120s does it need to go? The answer is 2. So when you explain this, you'd have to say something like, it will take 2 more, that's kind of sloppy, yours will be better. It will take 2 more turns of 120 degrees to add up to 360. All right, let's turn the page. This is our very last review sheet for Unit 8. I'm on page 346, and I have a map. Cross Street, West Street, and Carmichael Street form a triangle. Oh yeah, I see it. Look, they even, I wonder what they're going to ask. There's the triangle there that they form. I'll shade it in a little bit so we can see it a little bit better. How can the triangle be classified? Mark all that apply. So they're going to try to trick you here. There's going to be more than one right answer, just like our quadrilaterals that we were dealing with on that quiz earlier. So let's think, which of these would make sense? Let's go one by one. Is this triangle a scalene triangle? Remember, scalene means that all of the sides are different lengths. Yes, they are all different lengths. I have my long side here. Here's my medium side, and then this side over here is a bit shorter, so that it is a scalene triangle. Is it an acute triangle? Well, I remember that an acute triangle has to have 3 acute angles in it. Does this have 3 acute angles? No, it does not, because of that one right there that we see, and that kind of makes it obvious what that's going to be right there. Now let's look at the next one. Is this triangle an isosceles triangle? So thinking back, what is the definition of an isosceles triangle? Remember that that's the word that comes from an old word that means something that has 2 legs, so 2 equal sides. An isosceles triangle has to have at least 2 sides that are equal. And if I look at that triangle, I already said it was scalene. It can't be scalene and isosceles at the same time. It's not possible because of their definition. So nope, isosceles is not correct. What about a right triangle? This one, I don't know about you, but immediately when I solved the triangle, I knew it was right because I saw that square there. So that one's easy for me. Yes, I know it has a 90-degree angle. That means that it is a right triangle. Remember that a right triangle only has to have one angle that is a right angle. It can only have, there's only one possibility of that actually. What about an equilateral triangle? I remember that equilateral triangles mean that all sides are the same length. That would totally not be correct because it's scalene. So once it's scalene, these two can't be correct anymore because automatically all of the sides are different lengths. We already know that. Hopefully that makes sense the way I said that. And then obtuse. Is this an obtuse triangle? Again, I remember that an obtuse triangle has to have one angle that is obtuse. This triangle has one right angle and 2 acute angles right there and right there. So no, sorry, it is not obtuse. It only got 2 correct answers. You'll have to be really careful when you take this test because there'll be questions like this and you're going to have to be able to identify all that are correct, but make sure you don't accidentally choose the ones that are not correct. Number 19, a stage has 4 sides with exactly 1 pair of parallel sides. Marjorie says the shape of the stage is a quadrilateral and a rectangle. Do you agree? Okay, so we have 2 shapes, she's saying. We have to see if it is one of those or both of those because she says it's both. 1 pair of parallel sides. Okay, so if I was going to draw a shape that only has 1 pair of parallel sides, I might do that for my parallel. Those are parallel, but one of them I'm going to make longer than the other so that this side and this side are obviously not parallel to each other. See how this would eventually meet that, so I know that those are not parallel. So that's the shape I made. First, is it a quadrilateral? Yes, it has 4 sides. Is it a rectangle? No. If these 2 sides are not going to be parallel, which they can't be because it only can have 1 pair of sides that are parallel, that means it can't be a rectangle because you're not going to have right angles. there are not right angles here and here. Even if these were right angles, which I don't think my drawing quite did make right angles, but let's just pretend. Even if it does have right angles up there, these are not, so it is not a rectangle. In my explanation, I would have to say something like, no, I don't agree with her, because yes, it's a quadrilateral, it has 4 sides, but it's not a rectangle because it does not have 4 right angles. Therefore, it cannot be a rectangle. Okay, last one, number 20. What is the unknown angle measure in this pattern? Okay, again, this is going to be one of those where you have to have some information memorized in order to get it correct. So here's my question mark. What do I know about a straight line or a straight angle? I know that it measures, hopefully you have this memorized by now, 180 degrees. So if I took 180 degrees and I subtracted 55 degrees, 180 minus 55, you would do your work on paper and pencil to double check me, is 125 degrees. So that's how I would figure that out. Okay, 4th graders, this is your last review sheet for the test. If you need to watch these videos more than once, I highly recommend doing so before you take the test on Thursday. Thank you very much.